Hello, good morning class. Hope you are all fine. Now we will start practical number 10, colloids. Dear students, you must have heard about colloidal solutions. Colloidal solutions are intermediate between true solutions and suspensions. If the size of the particles are between 1 nm and 100 nm, the mixture is known as colloidal solution. So, what is colloid? A colloid is heterogeneous system in which one substance is dispersed phase as very fine particles in another substance called dispersion medium. Here, one thing is very essential. Difference between a solution and a colloid is that of particle size. While in a solution, the constituent particles are ions or small molecules, but in a colloid, the dispersed phase mainly consists of particles of a single micromolecule such as protein or synthetic polymer. So, colloidal particles are larger than simple molecules but small enough to remain suspended. As we know, their range of diameter is between 1 and 1000 nm. A solution is colloidal solution of solid in liquid based upon the affinity between the dispersed phase and dispersion medium. Colloidal solutions are of two types. First, Lyophilic colloids. Second, Lyophobic colloids. First, we will learn Lyophilic colloids. What is Lyophilic? Lyo means solvent, philic means loving. In these colloids, both the dispersed phase and dispersion medium have great affinity for each other. Example like starch, gum in water. These are normally stable and can be easily prepared by mixing the dispersed phase and dispersion medium and heating if we required. So, if the dispersed phase gets separated from the dispersion medium like evaporation, the salt can be reobtained by simply mixing two phases. That is why these are also called reversible colloids. That means Lyophilic colloids we can say as reversible colloids. If water is the dispersion medium, it is called hydrophilic colloids. Now we will learn about Lyophobic colloids. What is Lyophobic colloids? Here Lyo means solvent and phobic means heating. In these colloids, both the dispersed phase and dispersion medium do not have affinity for each other. Rather, they hate each other. Example like sol of ferric hydroxide, aluminum hydroxide, arsenious sulfide in water. These sol are normally unstable and two phases try to get separated from each other. This sol can be prepared simply by mixing two phases and have special methods of preparation. Example like sol of ferric hydroxide, aluminum hydroxide, arsenious sulfide in water. These sol are normally unstable and two phases try to get separated from each other. This sol cannot be prepared by simply mixing two phases and have special methods of preparation. Here for lyophobic, preparation of lyophobic sol, we will do the dialysis. We will learn later. If two phases get separated from each other, example like evaporation, the sol cannot be reobtained by simply mixing two phases. That is why these are also called irreversible colloids. That means lyophobic sols, lyophobic colloids are irreversible colloids, and what is our first? Lyophilic colloids are reversible colloids. So here lyophobic colloids are irreversible colloids. If water is dispersion medium, these are called hydrophobic colloids. Theory for lyophilic sol: starch, gum and egg albumin forms a stable hydrophilic sol. However, the preparation is carried out with boiling water for better and quicker dispersion of starch into water. Here the theory of lyophilic sol of starch. For preparation of lyophilic sol of starch, chemical required: 1 gram starch, second distilled water. Precautions: the starch powder should not be added directly to boiling water. Instead, a thin paste should be prepared and added. The contents of the beaker should be cooled down to room temperature before filtration. Here, lyophilic sol of starch in last we will get filtration. That filtration is our lyophilic soul of starch. In next video I will show you how to do preparation of lyophilic soul of starch and lyophobic soul of ferric hydroxide. So students, here we have learned about colloids, lyophilic and lyophobic. Now we will do the theory of how to do our particles going on. So we will start the preparation of lyophilic lyophobic soul of ferric hydroxide. Aim to prepare lyophobic soul of ferric hydroxide. Theory: ferric hydroxide forms a hydrophobic soul. Hence, it is prepared indirectly by the hydrolysis of ferric chloride with boiling water. The chemical reaction takes place as, see the equation, the ferric ions Fe+3 produced from FeCl3 solution are absorbed on the surface of the particles of ferric hydroxide. As a result, the colloidal particles of ferric hydroxide acquire positive charge. Hence, because of similar charges on the colloidal particles, they keep on repelling each other and can't come together or aggregated together to form bigger particles. This prevents their coagulation and is responsible for the stability of the soul. However, the HCl formed along with ferric hydroxide destabilizes the soul. Hence, HCl, being an electrolyte, can be removed from the colloidal sol by dialysis. Another important point: during the preparation of this sol is that as presence of ions destabilizes the sol. The flask in which the hydrolysis is to carried out must be free from all types of ions. Here we will learn what is dialysis. Dialysis is a process of removing a dissolved substance or electrolytes from a colloidal or a sol by means of diffusion through a suitable membranes. For lyophobic sol of ferric hydroxide, dialysis is a method of purification of sols. When a colloidal solution is kept in a parchment paper, which is then placed in a solvent. The ions diffuse out the parchment paper, whereas colloidal particles can't. So, dialysis is a method of purification of colloidals. So students, here we have completed practical number 10, colloids, by theory of Lyophilic soul of starch and Lyophobic soul of ferric hydroxide. In next video, I will show you how to do preparation of Lyophilic soul of starch and Lyophobic soul of ferric hydroxide. Till then, bye and take care.